and ask you kindly if everybody can turn off his camera and microphone so we can see and hear speakers on stage. As always, I'm going to be co-hosting with Eric Wallstad this session. I'm Omar Saadoun. I'm co-founder and CEO of InMind and a blockchain software engineer and part of the Eternity Americas team. As a remembering of what Eternity blockchain means, I always like to explain that it has been built from scratch to be the next blockchain generation. With state channels, fast and low cost transaction, and oracles and naming system. But the way we have a couple of surprises today related to that, and the best developers team. Today's agenda is composed by 3 presentations and Ask Me Anything track at the end. And then we're going to be switching to the networking area. Our first presentation is going to be handled by Emmanuel Joseph. We know him as Jet from Nigeria. He's going to be showcasing AEtweet and HMS systems developments on top of Eternity blockchain that was made during the Ekiti Study Jæm. And the following presentation is going to be done by Arjan and Eersel about a very interesting topic, closing the gap between public and permissioned blockchains. And we will have Filip Piwowarski, Pivo, talking about his experience and what he thinks are the best practices on building apps. And at the end, we will have our Ask Me Anything section with the core dev Dimitar Ivanov. I would like also to explain, Eric, do you want to explain how the tokens are going to work?
Yeah, sure. So yeah, today we want to start to incentivize a little bit the use of our naming system. So probably some of you already have them, but in case you don't have them, you can ask me and I will explain you in private how to create a .chain name. And if you have any like technical questions about it, you can also ask in the end and ask me anything. But I think it will be a great experience to simply get used to tipping each other's for cruel content, but also just in general to get used to that you can use the .chain name also to send value and to send tokens.
Cool. So have your questions ready? Very good questions, by the way, and so we can hear it with and see what the speaker has to say. Okay, let's move on then. Our first presentation is from Emmanuel. I will remember to anybody who Emmanuel is. Emmanuel Joseph is a full stack web developer that makes use of Google and Aeternity tools in his software development career. His vision is to impact young minds and his love for community building. And that's what he led him to work on the development student club for Ekiti State University in Nigeria. And he is also an Ekiti ambassador, top 3 on the CAD, and almost a year being part of the Eternity ecosystem. He created Jæm, that is a developer study, and taught software to software students about Sophia for 4 weeks. And today we are going to be seeing about AEtweet and hospital management system. So let's play Emmanuel's presentation and have you hear Emmanuel for questions at the end.
Hello everyone. I'll be talking on 2 apps developed during the Developer Study Jæm workshop at Ekiti State, Nigeria. So I am Emmanuel Joseph, Jet, Eternity Ekiti ambassador, and could be reached via mail at jet@ekiti.com. So Ekiti is a community of techies utilizing authentic technologies, and anticipate website update soon, as we're currently adding some features, interesting features on the website, which is at ekiti.com. Yeah, so the 10 weeks of teaching authentic technologies in Ekiti, Nigeria, ended with the Germans building decentralized apps that got them the $75 bounty on that kit. All 10 plus apps can be seen at the guide created at ekiti.github.io/AEPPS, which is absolute. It is AEKITI.github.io/AEPPS. So in this session, I'll be talking about, or I'll be talking more on two of the apps, which is AEtweet and HMS. So AEtweet. AEtweet is a decentralized app built using æternity technology and JavaScript by Yinka Adedokun. The apps mainly run on æternity blockchain through Sophia smart contract written, and it connects with the user interface using æternity JavaScript SDK. So AEtweet is a streamline of Twitter that has even the user interface similar to Twitter, and it was built to make users feel they are on a decentralized Twitter. So one of the cool features of AEtweet is the ability to receive tips from anyone on the platform, which makes a user more popular or highly rated through the amount of tips or AE he or she obtained from the tweet. And a major push that inspired the thought and the creation of this app is the medium clap features. You can actually learn more about AEtweet from the video created by the jammer himself, where he explained the app and also the codes, including the smart contract and the JavaScript explanation. So I'll give a run through of the app, where I would show one or few things on the app. So first thing I will do is to go to the guide link, which is ekiti.github.io.apps, and the guide link has actually been updated than before, in which you can now click on app names with this color to show you the jammer's picture, including his score on Jacket. So this is AEtweet. Click on this. This is Yinka Adedokun, and he actually scored 14/20 on Jacket. And if we check on Right At, this is Amaka Abaka, and she actually scored 20/20 on Jacket, which was really amazing. And so on. We have Tosi, who actually scored 16/20, and so on. We have Jules, this is Ahmed Julala, that scored 19/20. So let's move into the review of AEtweet. So the guide has actually been updated in a way that if you're on desktop view and you click on the C app link, it actually opens a new tab with the app URL. But if you are on desktop, and if you notice, it keeps loading because it mainly runs on an æternity blockchain. If you are actually on mobile view and you click on the C app link, it actually opens Base app, and it opens the browser and then the app. So I'm just going to close this and take this back to desktop. And since I've opened this here, I'll copy this link, cut it rather, and then so I topped up my wallet, and would add the link here instead. Yeah, so it's opening. Cool. Now we have this is the user interface with Twitter color, and makes the user feel okay. I'm still on Twitter, something like that. So we have this user 001 was trying out, and I think is the highest. He has the highest amount of tips, which is making him the highest or the first tweet to be seen, which is how the AEtweet app was built. So let's see. Let me create one and call myself Emmanuel. And my avatar. Let me get one from Ekiti.com. Just want to get the URL here. Okay, yeah, this is me. I'm gonna copy the address. Come back to this and put that there, and I just say amazing. Now let's see tweets. So it's loading the contract call, and I'm going to confirm that. Great. Where is my tweet? Okay, I think the page that is loading. Let's see. That's not my tweet. Oh, okay. This is my tweet. Amazing. Presently, because no one has tipped me, I have 0 E. At the moment, I think a user can actually tip his own tweet, which is working on to actually make this now happen. So let me just see. I'm going to tip myself for 20. Okay, good. Okay, now I have 20, and now I'm above this tweet with this. So if I actually have a tweet above this, I will actually come first and become the highly rated and most popular tweets, depending on how much tips you get by your tweet. So if I say, let me give this guy, let's just say 20 AMs. Is this 20 AMs? Let's just say that. So just 20 equal A. Okay. All right. So where is it? Yep. Now I'm above everyone. And it's showing you the amount of tips that actually got this user to this level. So if, as you can see here, it's saying 2 tips. So this user got to this position because of these 2 tips. This is the total tip. And this user got to this position with 1 tip. And this user with 8 tips. This with 5 tips. And this with 3. This with 3. This with 1. So that's basically 8 tweets. You can add another tweet, and yeah, so that's 8 tweets. So let me now move to the second app, which we have to talk more about, and the name of the app is HMS, which means Hospital Management System. So what is HMS? So HMS is also an app built on Eternity blockchain. It was developed by Vivo Additional, and it also runs using Sophia smart contracts and Eternity JavaScript SDK for the contract calls. So HMS, as the name implies, is an app built not just for hospitals but for all healthcare services. And HMS actually helps to keep patient records, including all medical treatments given to a patient by a particular doctor. So one of the amazing features of HMS is the restriction functionalities in the smart contract, where there is patient, doctor, and admin role. A patient can register for free, while there's a payment of 2 AE for doctor's registration, and the admin has the right to see all the data. And you can also learn more about the app, including the clues on YouTube, using the links, the YouTube link shown. And I would also give a run through of the HMS app to actually make you see how it looks like. So let me go back to my guide. This is my guide now, and this is HMS. Let me click on see app link, which is opening a new tab. I'm going to copy this. It keeps loading here because we're not one load and stuff. So I'll go back here. So I have created my accounts on testnet with 5 AE each, so I can actually test these different roles. Though I don't have access to the admin, but I would show the doctor and patients. So I'll make this guy patient. So let me just come here. Good. Okay. So we have patients and we have doctor. As I said, doctor registration costs 2 AE, while patient registration is for free. And right here to have the home, just taking here we have the patient and we have the doctor. So I'll make this registration for patient. So patient is just training name. Let me just write test user and select one. Okay, say female. So image. Okay, let me select an image. Okay, let's just pick one from here and just pick this. Just see. Voila. Oh yes, the image stored. The image are saved using IPFS, and the IPFS hash is actually stored on the blockchain and retrieved later on. So on HMS app, it makes use of IPFS technology to actually store and retrieve images. So let's see. This should be my internet. Oh, okay. We actually have this decoded error saying owner only. So I guess that's the function that is actually showing all the details. And because I'm not an admin, I won't be able to see that. So yeah, I guess the image has finally gone to IPFS and we've gotten our hash. So I'm going to confirm the contract call. And now we have an hash saved, and yeah, so we have the hash saved on the smart contract, and we're getting back the image, the name of the user, and the sex of the patient. So now we have my medical records, which is empty at the moment because the doctor has not actually done anything. So before, okay, let me make a doctor registration on another account. Let me refresh here and allow this. Okay, but want to do doctor registration now, and let's just say test doc, and also the same thing using IPFS for the doctor's image. I want to pick another picture. Let us see. Okay, let me just go with this. And, this. The same thing is happening again. The image storing using IPFS. Now it's faster. I guess my internet is faster now. As you can see, it's actually except for the payment of 2A before you can actually become a doctor. So, I guess I'm now a doctor. I would have my image. Yes, now I have my image. I have my name, test doc, and yeah. So now as a doctor, I now have access to this form, which is the add medical record form, in which you can pick when you want to add a record, you actually pick the patient. The doctor has access to pick the patient, and then administer the treatment. So we have this list of patients on the system. I guess our account was test user. So I'm going to click on this. I'm going to let's see, patient height is 45, weight is 65, let's see, 45, genotype, let's see, let's just see, and yeah, let's just see O plus. And medication given, let's just see, what can we use? Let's see, corona or something. And let's add patient, let's add the medical record. So now we have the contract call, and I'm going to confirm this. And yeah, now we have this, and now I'm going to go back to the test user to actually see if he now has a treatment administered to him. Okay, now I'm in my patient user. I'm going to reload. And the reason for this is because at the smart contract, the list, the patient list, and to get the patient is mapped to an address. So it's the caller of that function that actually gets to see the details alone. So yeah, we have our test user now, and we have this medical records where on this date, Wednesday, April 15, 2020, this doctor, test doctor, actually made this treatment, and the height, weight, genotype, blood group, and the treatment medication given. So, okay, I'm going to create another doctor and add a treatment to this same user. So I'm going to do that with this account, and load this just so you can see at the medication given, the doctors actually choose, and the doctor, so when the admin is actually seeing all the details, says, okay, who gave this medication, which patient was it given to. So doctor registration, let's just say doc 2, and okay, okay, let's do this, and submit this again. All these error messages, the coded errors, are just because it's not an admin, so this address is not an admin, so that's why. Now we have doc 2, and given it to test user. So let's see, let's put digits, number, type, let's see, yes. Let's just put anything here. And And here, let's see, fever plus what's corona. So now add medical record. So contract score, approve. Great. Now that has also been recorded, and as you can see, there's this also. So, let me try to. This is a doctor, right? Let me try to doc. Let's just say doc P, and just try to pick that same image. Submit. Okay. Oh, so now it started as a patient and also a doctor, and his name, Doc P, would also be listed there, which you can actually treat as which is not good, but yeah. So let's now go back to our main user, patient. Reload this page. Let's see. Okay, yeah, we have the test user, and now we have this also. Now, if you notice, the first medication given goes down, while the second medication comes up, and it continues piling up like that. We have this, the doc2, and yeah, so that is the HMS app, and yeah, these are the two apps I would be focusing on in this session, and all the remaining other apps are actually on the app guide, where all other apps are also working well, and the apps with this color has actually been built on Darkade and stuff. So yeah, and these two other apps were apps built before the developer study jam by the co-lead, æternity co-lead, by this by me, and this co-lead, what is called 16, and so yeah, you can also check through this link here to actually go through the whole apps built by the Jammers, the whole playlist. Because each Jammers app was added to playlist here. So we have 10 videos, which are 10 from different Jammers. We have the split management system, we have the ride ads, we have this. And yeah, and you can actually also see other stuff on Eternity, channel, Eternity Ekiti channel. We have videos about developer study jam in case a developer would love to get started with Eternity technologies. And we have introduction to Sophia, integrating smart contracts 1, 2, 3, 4, where we built a book library, and then we use that PFS here to actually store and retrieve book image. Yeah, so that's that about me, the test of jam apps for this session. And yeah, thank you. You can always reach us on ekiti.com and on our Twitter and also on our Telegram. Thank you.
Thank you, Jet, for this presentation. We look forward to see the other apps. Are you there, Jet?
Can you hear me now?
Hey,
yeah, yes, we can hear you.
Great.
So you were saying that this is the work from different students. How many students were working on every particular app? Is it one per app or more than one?
one per app.
Cool. And how much? How is the? In which way? What is the process to be working with every student? Do they propose the idea? They start working. How is that process that you take with them?
Okay, great. Total for the Depth Study Jam, we had around 20 RSVPs who were interested in linear times technologies. But along the line, we had 15 developers who actually stayed throughout the Study Jam series. Why we had 10 apps at the long run. Each student, because of their level of understanding their stack, some students were fully PHP developers, some were JavaScript, some use Flutter and the like. So we had to take a JavaScript workshop first to actually explain more on JavaScript, just so that the students could be of the same level. And when introducing Eternity JavaScript, using Eternity JavaScript SDK, it won't be an issue. So after the JavaScript workshop series, then we moved into Sophia, where we had Moritz explaining Decade and how to earn tokens on Decade. He gave us the tips, what to do, what not to do, how to make your app qualify by adding more functions and making your app cool and much more documented. So after Moritz review, we started teaching Sophia from scratch, which we made use of the videos on Decade, and after that, we make use of the documentation hub, where we actually had access to check through some new functions that were not added during the Decade videos. So we explained those functions, we used list, we used map dot delete, map dot size, and length. So we overall, all I could say is we just had to make sure the jammers are in the same position. So when we introduce something new, they could all grasp. Though some learners don't have the same learning speed or learning pace with the others, in which we did personal tutorials for those learners. Because the Study Jam series was for every Mondays and Wednesdays, while there were some times where we did Saturdays extra class and some classes on WhatsApp, just so the jammers could understand the technology and make use of it, and then build apps on technology.
Cool, great. And what's just I'm curious. What's the average age of these students?
What's the
average age? How old are they?
They are above 18. And because they are all students of Ekiti State University, while some of them are not students, in which they saw our flyers outside the school and they actually joined us. So for their development code, some of them have been developing for the past 1 year, the past 2 years, because we had majorly 300 level students, while most of them were 200 levels, and we had developers which were outside the state university.
Cool. Okay. Thank you. I don't know if there is any other question from the audience. We had someone from Milan, I think, but he answered itself. So if there isn't any other question, I will give you thanks for this presentation, and I look forward to have all of the Ekiti apps presented on the following sessions of SuperheroLeague.
Yeah, and for those other sessions, I would try as much as possible to actually touch some codes, maybe the JavaScript and also the Sophia, and actually describe and explain what he or she meant when he added the function or that parameter.
Yeah, that would be great. That would be great. Well, thank you very much, Emmanuel, and we will move forward with the presentations.
Thank you.
So our next presentation is from Arjan van Eersel. I hope, Arjan, I'm spelling the right way. He is the ambassador for Bulgaria and Lithuania, and he comes from the world of corporate services and has been a consultant for international business and taxation for many years, while also coding on internal and open source software projects. Now, with his business domain knowledge and coding experience, his company is working mostly on delivering software which uses modern technologies such as blockchain and self-sovereign identity for the corporate service sector. Arjan will be presenting something I think is very interesting topic about how we close the gap between permissioned and public blockchain. So let's see the presentation from Arjan, and please have your questions. I'm pretty sure that there's going to be some of them for Arjan to answer at the end.
Hello, my name is Arjan and I will talk in the next 20 minutes about closing the gap between permissioned public blockchain. I have a background in IT and corporate services and currently work as an independent software and blockchain developer. I'm also Eternity lead ambassador for Lithuania and Bulgaria, as well as a certified developer for Tezos, Hyperledger Fabric and Hyperledger Sawtooth. Now, unlike many other people, I didn't make my entry into blockchain via crypto-based public blockchain. My first experiences with blockchain was actually enterprise-grade permission blockchain. Yet I joined the Eternity community, and not without reason. As a developer, I very much care about value over technology, and therefore I work with different technologies, and that includes both public and permission blockchain. Because every use case is different, and every use case has its own unique solution. In this presentation, I will explain why permission blockchain exists, because I think it is important to close the gap between these two worlds within blockchain. Most blockchain use cases, at least the ones I work with, aren't so black and white that they can simply be thrown on either a public or permission blockchain. And that is why it's important for these worlds to grow much closer to each other. Now, enterprise-grade blockchain differs from public blockchain because it adds elements of permissioning, and it has a different focus than most public blockchain systems. Many enterprise blockchain applications rely upon real-world trust relationships, and the goal is to set up participants in an ecosystem which has the needed insurance that it's flexible enough to bring more participants together and in the network in the future. Most enterprise blockchain systems are also not crypto-based, but leave an eventual token implementation up to the developers, as well as the decision to have a token at all. Now, with public blockchain, everyone is kind of anonymous. As long as you don't reveal your wallet address or register something like arjanvaneersel.chain at the Eternity naming system, then nobody will know to whom that address actually belongs. With permission blockchain, this is very different, especially consortium style blockchains. There, we know exactly who you are. We know exactly what you can do, what you may do, and what you are in fact doing. This is not a design flaw. This is done deliberately because the use case requires so. It was in fact never meant to be a public system, but instead a tool for different parties to work more efficiently by sharing an immutable infrastructure. One of the criticisms against permission blockchain is often that people say, but it's not really decentralized. And I agree to some extent. If you look at things from a technical perspective, then yes, we might argue and have a debate how centralized or decentralized permission blockchain in fact is. However, the truth is that most use cases with enterprise blockchain are mostly about data decentralization. This is so much more important than technical decentralization, especially in those networks where we already know anyway who everybody is. But what really matters here, as I said, is that there's absolutely no centralization from a data perspective. Some use cases also require a higher degree of security, for example, role-based access control. If you come from public, fully transparent blockchain, then you might not like the idea, but there's a reason. It even makes sense in my opinion, because when we are dealing with business data, and that's what we're talking about, then an auditor should definitely have a higher degree of access than your competitor. The community of participants uses the system, just as with public blockchain, to record promises, trades, transactions, whatever things they don't want to disappear. However, under different circumstances and conditions. Now, a real use case I'm working on is a system for regulatory compliance. Here we are talking about regulators and regulated companies using the blockchain to deal with regulatory reporting requirements. Here we are talking about a very conservative world. A world which has absolutely no affection towards blockchain. So getting people enthusiastic for blockchain is already a challenge on its own. Some of the criticisms which I heard when discussing the different technology options, not willing to accept cryptocurrency-based solutions. Unfortunately, this is the way things are at the moment. Some people will simply reject a perhaps superior solution just because they don't like crypto. And although this might sound pessimistic, it is in fact normal if we consider the current state of blockchain. We are all early adapters. Blockchain is still relatively young from an adoption perspective. And it's going to take a while for crypto to become mainstream. Another thing, and I think we can all relate. We meet a person and then the person asks, what do you do for a living? So I say, I'm a software and blockchain developer. And then you see them think. And they think, and then comes the question, what is blockchain? Then imagine trying to get people together on the same network. They already don't trust each other at all. For example, because they work for competing companies. And then not having a clue what the technology is about and trying to explain the benefits of sharing their infrastructure. And when you accomplish that they accept the idea of blockchain and having this shared infrastructure and what the benefits are, then still what was the number one thing for them to accept it is that their vital business data is protected and only shared on a need-to-know base. So that means in this use case between regulated companies and the regulator. Now, why did they reject public blockchain solutions? Well, the regulators did not like the idea of cryptocurrencies at all. They were not even willing to consider. The regulators' companies were, not without reason, very protective regarding their business data. And this is data, if in the wrong hands, which could seriously damage their business. So of course they are careful, of course they are skeptical. And therefore these companies did not like the idea of some random nodes having their so valuable data. And they liked the idea of their competitors' nodes having this data even less. And even if it would be in an encrypted form, it was simply a no-go. So the technology stack that was chosen for this particular project was Hyperledger Fabric. And why? Well, Fabric allows to create a consortium-style blockchain, and that is what we are talking about. This is not a blockchain that simply everyone can join. It's in fact a closed ecosystem of known participants sharing a single or limited set of goals through a common infrastructure. And Fabric has this very powerful feature called channels. I won't go very much into the details of Fabric channels, that's not the purpose of this talk. So I will say that these channels are somewhere between state channels and subchains. And in this use case, regulated companies had an individual channel with their regulators. And in Fabric, channels have their own ledger. And this way, regulators would see the transactions in their own jurisdiction, and regulated companies could be sure that nobody else than the regulator had access to the data which concerns them. So, on the channel, there would be the regulator and the participant. Competing participants, competing companies would never be on the same channel. Neither would regulators from different jurisdictions ever be on the same channel. So this way the regulators only had access to the data which concerned their jurisdiction, and competitors would also never see each other's data. So why doesn't everybody use permission blockchain then? Well, the truth is that the use case which I just explained is kind of an extreme situation. And this is really a very typical consortium style blockchain. Many enterprise grade blockchain use cases aren't even suitable for a consortium style blockchain because they have elements of both private and public data. So using such a closed system would definitely be a wrong choice. And that is why, in my opinion, it is very important for public blockchain systems to close the gap with permission blockchain. As I said, most use cases are a mixture of private and public data. They require a philosophy of private what can be private, but public what should be public. And that means that they in fact go semi-public, as I like to call it. And that means that the network becomes a concern. I think we can all remember certain Bitcoin forks. They got a lot of attention even. And these are forks of which everybody would reasonably think that it would be easy enough for them to get enough of nodes in the network. Yet they still became the victim of a 51% attack. So if this is already a concern with famous forks of famous blockchain systems, then imagine how difficult this gets when we're talking about something which is just semi-public, and especially if there's not even a rewarding model for network participants. Yet getting the network right is vital to guarantee stability and data reliability. So now that you have an idea about why organizations might pick private blockchain over public blockchain, as well as a rough idea of private and permissioned blockchain, let's talk about Aeternity, and let's realize that also Aeternity offers many facilities which could help to solve these typically enterprise-grade blockchain problems. Now, the most obvious one is that in Aeternity the network is not a concern. I mean, Aeternity already has a blazingly fast and reliable network. So, here's a very clear advantage. State channels, yeah, they might not have their own ledger, but they do offer a form of privacy which will do just fine for many enterprise use cases. What happens on the channel stays on the channel. What needs to be public can be published as public to the blockchain whenever that is required. And also, believe me when I say that setting up a permissioned blockchain network is anything but easy. So why not consider launching a private Aeternity network when all we need is in fact a slightly more private blockchain? Dapps could, depending on the use case, run on either the public or private network and then easily interact with the other network. And then add to that the other conveniences like Oracle integration, the naming system, and I think it becomes quite clear why Aeternity also has a lot of potential to deal with those typical enterprise grade use cases. I don't have the time in this presentation to show a demo or even a technical explanation about state channels or launching a private Aeternity network. But I do recommend the videos which you see here. They are definitely worth watching if you're more interested in state channels. This was it for me. I hope that this presentation was interesting for you and that you got a better idea about permission blockchains and why they exist, as well as having ideas to discuss this topic further and to have some exchange of ideas how we could use Aeternity to solve these issues, and perhaps even for a future development of Aeternity to at least think about whether it makes sense to implement some elements of permission blockchain into the Aeternity ecosystem to also serve these use cases in an even better way than is already possible at this moment with Aeternity. I thank you for your attention, and if you have questions, then I'm here online to answer your questions, and I'm happy to do so. Have a nice evening.
Awesome. Well, thank you very much for your presentation. This is a very interesting topic, and at least in my case, every time it pop-ups on discussing what is best, and for me, it's not that there is one that is best for or the other, right? It's more that there is some scenarios when it makes sense to apply a permissioned blockchain, and some scenarios where there is no room for that. So there is also one thing I always say, that for permissioned blockchain, you have to manage, ideally, you will be managing your own infrastructure as a company, as a corporation, as anything that will need that permissioned blockchain. And on the open blockchain, you may have options where you don't really need to have your own infrastructure. It's much better to have it because you won't be relying on other people's infrastructure or trust on their infrastructure, but you still have that option, right? So how you deal with that kind of explanation, thinking about from an infrastructure perspective?
Yes, that's exactly what I tried to say in the presentation. I mean, when we're talking about these typical consortium-style blockchains, there we have a certain amount of players in the blockchain and parties that will be added. It's never going to be a lot of parties. So there, the network and even some elements of centralization isn't really an issue. The problems are going to start when you go outside of the scope of consortium blockchains, and when you go semi-public or maybe fully public, but trying to do it without crypto, then you're going to get in exactly those issues which you mentioned and what I mentioned in the presentation. The network is going to become a concern. And what is the right solution? Yeah, it completely depends on the use case. What is possible? They are all different. In the example that I mentioned, it was clear this could never run on a public blockchain. It wouldn't work. But there are many use cases in a much more gray area where it definitely makes sense to use public blockchain even for enterprise purposes, or as I mentioned, launch a private network for those parts that need to be private. With Eternity, that's definitely doable, and things are not too difficult to get them interact with each other, those two, the public and the private network.
Okay, thank you. I thought it was my connection again. Let's see if we have other questions from the audience. Otherwise, I have a couple more. Eric, any question for Arjan?
Yeah, maybe not so technical one, but Arjan, you have worked in both environments with the private and with the public blockchain, and not regarding the technical aspect, but more about, let's say, the culture of the people around it. How would you say is the difference between, like, is there a difference in the culture of the people, or is it the same?
Oh, there's a very big difference, and it very much matters also on the jurisdiction. I'm very much focused on regulatory technology, and it's a world of difference. If you're dealing with, let's say, the Baltic states, Lithuania, they are so open, even to crypto-based solutions. Or, for example, Bulgaria. I mean, the Bulgarian government, I'm not even sure if they understand what blockchain is. Let's not even talk about crypto. So there are really big differences, and that has nothing to do with the technical aspects, but it's all a matter of perception and opinion, and sometimes even bias against crypto. For whatever reason people might have that. It happens.
And would you say it's similar to the comparison between the intranet and the internet and the beginning of the internet?
I think there it was a bit easier because you weren't really changing things in economical processes, and blockchain is quite disruptive, and especially for regulations, it can mean so much, and it can make life so much easier for companies to comply with those regulations. You don't want to know, for example, the financial sector
with what kind of outdated systems from somewhere in 1900 and Flintstone they are still working. And a blockchain, it's going to make such an incredible change for them and make things so much easier. But the most important thing is their willingness to consider the technology. And as long as people think blockchain, crypto, that it's a synonym, we're on the wrong path. And we as a community definitely have a task to educate people in this area and to explain them that blockchain and especially crypto is not that scary as some people think it is. And hopefully when they see the benefits, they will be more open to adoption of blockchain-based solutions, even if it's crypto-based.
That's an excellent point, Arjan. That's an excellent point. We talked about this the last time when we end up on the same situation. We as technical developers, we understand how this technology works, but we have a great job ahead on explaining to regular people how much it can improve a lot of things, but also that implies to bring it to the real life. It's not just about explaining, look, a blockchain is something well used, is very secure, that you can have control of your information, you can have control of your money, because at last somebody will ask, well, what if I lose my privacy? Well, you will have some problems. There is no bank where you can knock the door and ask for some help. So there is a huge gap on everything we can do and how it has to be done, and how we explain that to the average guy, the people that is walking on the street right now. So we have a very big challenge ahead, and the adoption is going to be step by step, and it's not going to be easy. And also we have the central entities where they need, or maybe they understand today that controlling the entire information is the way that they can lead and they can rule a government, right? So there is so many things, so many aspects from technical to the real world that are in place on all of this, that is something very, very, very important to explain, to show, to teach, right?
Yes, absolutely. And one other thing which I could add to the question of Eric and the comparison with intranet and internet, an intranet would be something for usually for a company internally that they would use. But in blockchain, we deal also with a very different infrastructure. And in the use case which I had in the presentation, I was talking about competing companies sharing their infrastructure. Now, as blockchain people, I think it's quite obvious that there's a benefit for them. It will save them enormously in costs if they would share a blockchain-based infrastructure. And it's the immutability which protects them. But getting people, especially from those conservative worlds, they are not tech-savvy people, not at all. And convincing them that they should be together with their competitors on a blockchain-based system, that really is a challenge.
Totally agree. Okay, let's see. We have any other question? I want to hear somebody from the audience. Otherwise, I will be earning all the tokens for myself. And well, I have to share some with Eric. Somebody. Okay, well, thank you, Arjan, for your presentation, for being there to answer our questions. I look forward to have more about state channels maybe on the near future.
Yeah, me too. And you're welcome. It was my pleasure.
Thank you. Thank you very much. Okay, let's move on to the next presentation. It's from Filip Piwowarski. Pivo. He's an Eternity smart contract and code developer. Has been with blockchain for a long time now and a software developer. He loves bringing his passion and knowledge into developing scalable and innovative solutions, as well as educating others about blockchain technology. He will be presenting about best practices for coding apps, and he will be sharing his own experience on working on the different apps he has. So let's see and hear Pivo's presentation. And once again, have already your questions for Pivo.
Hello, welcome to the dev track of the SuperheroLeague. My name is Filip Piwowarski, and I'm an app developer at Aeternity, and I will go over the journey of building an app on the Aeternity blockchain today, together with you, and what me and my team learned building the graffiti app last year or early last year, and the governance app in the end of last year. And now we're working on the superhero app actually. So first of all, what is the graffiti app? We build a graffiti style digital artwork on blockchain where anybody can upload an image. It will get transformed to a specific art style, as you can see on the right here. And the position and amount put into the blockchain is saved for each artwork, and in the end it will be an auction which single piece of art is included in the final artwork, and the whole artwork is publicly verifiable on the blockchain. What do we do here? As I said, all of the artworks are sold off in an auction where every piece is timestamped on the Aeternity blockchain, and the reference to the single artwork is saved on the blockchain, where the actual image is uploaded to IPFS in order for anybody to be able to download it and to assemble a final image. So anybody can go to the smart contract on the Aeternity blockchain, get the state of the contract, download the images from IPFS, and get the exact same result as the website or the app shows. Of course, all of our implementation is open source here. For the governance app, we implement a delegated weighted polling system where anybody can open a new poll, as you also see on the right here, with the title, a description, a link to a discussioning that's happening, and possible options to vote on. Any account holder of Aeternity can then vote on one of the options, and the stake they have in Aeternity at time of closing of the poll will be saved in favor of their vote. So it's a delegated weighted polling system. This also means I can delegate my voting power to another account, and this account can vote with my stake, and the results are counted by stake or by weight of this option. For this, we have to have a heavy aggregation that's happening back end side, but there's also some scripts for anybody to verify are the results that we show accurate, and they can do so only by running an Aeternity node and calling functions, smart contract functions and other functions using the Aeternity node. Of course, also here the implementation is fully open source. I want to go a little bit over the development challenges that we had developing both of those apps. The first is we have to have a decentralized file storage. The public gateways are limited. We had lots of timeouts working with IPFS, for example, so in the end we hosted our own node that then syncs with the main IPFS network, and anybody can request from another public node our files, even though our IPFS node is not public. we had the issue of slow clients. A web browser or mobile phone is not the speediest client. So a lot of our work is done on a backend, but all of the work that the backend does is publicly verifiable using scripts, for example. And in some cases we need to do heavy aggregation with thousands of calls to the blockchain. This cannot be done from the client side, as the user would have to wait for a long time in order for all of these calls to be finished. If there's some errors, maybe the result will not be final. So what we do here is we call the backend to do all of these things. They are cached, and the user can then choose to verify the results on a computer with some minutes of time. This is always possible and will yield the same result as the app shows. And also there has to be a user experience focus. The app should feel as expected from centralized ones. The user have a certain expectation. Clicking on a thing doesn't load forever. Query the blockchain will take some time, so we want to make it as speedy as possible. And also this is why we did choose to go for a public verifiable backend. And in some cases the visualization of historic data is not trivial. For example, we have to look at the past state of the blockchain, the past state of one account, to show and be able to verify the result. And we had to think about some things here that I will go into later, how we solve these challenges. Let me first jump into the app development that we had in general. So with the Aeternity ecosystem, we have some great utilities. There's very good hosted infrastructure now. A compiler in various versions is hosted. The latest node and middleware is always available for both mainnet and testnet. And in general, for developers, there's a very good tool set. There's a contract editor. Right now, the Fire editor is very good to use in order to test your contracts quickly. And contract testing and development tools, for example, AE project, in order to automate your contract testing. And of course, various SDKs. We use the JavaScript SDK in order to interact from the client directly to the Aeternity blockchain. The base app, wallet, Superhero wallet are all reliable identity providers, so we can access the account of the user without implementing public-private key and signing ourselves. And so the user can store his keys in a wallet that he trusts and just connect to the apps that we built. I think all of the APIs that we are using were very well documented. The JavaScript SDK helped us a lot here, and also the APIs of the node and middleware we were able to find very quickly. Another great tool that we had is the Sophia syntax highlighting in VS Code and JetBrains IDEs. I think every developer knows that syntax highlighting it's a very great thing to have. And of course the app boilerplate, that is a boilerplate with Vue.js in order to get up and running quickly, connect to the Aeternity blockchain, connect to the identity providers, and have a general Vue project pre-generated. And other things that were great building with Aeternity, it's such a speedy blockchain protocol, meaning if we do an action, it's very quickly confirmed. We can wait for transaction confirmation, signaling to the user that what he has done was successful. And yeah, there's great new features in Sophia every once in a while, so we can write every smart contract that we envision. The VM is very fast and safe now. It's a pleasure to work with. And the error handling across all of the tools is very good. When there's an issue with the transaction that we do, we directly see the error message that we were throwing, for example, in our smart contract, and can act based on this. So to conclude, app development is now easier than it was ever. It's approachable for all developers. It's very simple to get started. And Aeternity is a reliable and very performant blockchain to build apps on top of. We also thought of some basic rules to implement your own app. So the first one is don't over-engineer your app from the beginning. Start with a simple prototype and then go ahead and add new components to it. once the first thing is working, once your first tests were successful using your infrastructure, for example, or your smart contract, or validate your idea of a smart contract if it's doable quickly. Find your concrete need. Where do I need blockchain within my app? Maybe blockchain is just a part of your app, and so don't put all of the logic on the blockchain, just put on the blockchain what is needed here. For example, a verification or links to other data, or authorized users doing certain things, or spending of tokens and interacting with smart contracts where you need it. And consider using supporting infrastructure, as we do with using IPFS for storing bigger chunks of files that are not needed in our smart contract, but still having public access to those, or using a backend service in order to aggregate your data, but then also have it verifiable for the user. We put together a sample how to get started developing apps. So first make sure that all of your dependencies, when you work with a project, the CLI, the Node.js or JS SDK, you need to have the latest Node.js and Docker installed. Then you can go ahead and use the CLI, for example, to generate an account and use this as a basic wallet to testing. You can use the faucet in order to get some testnet tokens quickly to try and interact with the testnet for your tests. Learn Sophia at the link provided. It's a great tool in order to look at what the Sophia language has to offer for you to write your first smart contract. For this, you can use one of the contracts editors that we have. For example, Fire Editor. It's a very great editor to use. Once you go over developing a simple smart contract and you go into production mode and you want to test your smart contract, use a project to test your smart contract, write automated tests, and also deploy it to testnet, for example. And also it has some tools in order to deploy to mainnet in the end. And then in the end, you can start building your app, for example, using the app boilerplate, and integrate your contract using the SDKs, which is fairly simple. What are some best practices for building an app? So first of all, what we say is make it open source from the beginning. It will help you get feedback from the community, for example, in the Aeternity forum. And also, in general, if you need help from somebody, you can just point them to your source code, and somebody who has more experience can maybe point out quickly where the issue is, instead of going back and forth, oh, something is not working, I don't know what, and the other the person who wants to help you doesn't have an idea about your code. The next thing is that we encourage you to use a backend, but make your app also work without it. For example, if your backend is not available, just fall back to how the app would work if you don't have the backend, but don't limit the possibilities. Maybe it will be slower, or maybe some additional data will not be available, but in general it should work without the backend. But of course it can help speed your app up or provide additional data. And also what is a great help is a script for the users, that they can verify the information. If they're a technical user and they want to know what the app shows me correct, they can run this and verify what you show them. And also a single script is easier to read and understand than understanding the whole logic of your app. If you verify everything that your app shows within this one script and give it out, experienced user or interested developer can check the lines of the script and see what's happening here, and then compare this to the result of the app. And that's very nice for developers to understand and trust your app. What we always do is wrap the connection to the wallet in an extra utility file. So if you want to upgrade or support a new wallet in the future, it's very easy to get integrated. And when you're looking over the documentation that we have and you see something that's outdated or incorrect, that's not perfect yet, point it out to us in the forum, or just make a pull request in order to improve it. So what are some key components that we always use in our apps? So first of all, what we always do, we write a smart contract and we automate our tests. Every function of our smart contract is well tested. Every outcome that we have, that we expect, or where we expect an error, we test it, and we have a continuous integration there in order to see if we make changes to our smart contract or our logic, will something break. We see this in our automated tests and using CI. What was very helpful for us is using contract events and indexing them in order to gain access to historic data. For example, in the governance app, when you delegate your stake to another account, this delegation is saved as an event, and if you later remove the delegation, the past delegation is still persisted in the event and you can access it at any time in the future. It's just not stored in the current state of the smart contract anymore, but it will be persisted in the history of the blockchain. What can be nice as well is outsource logic to the smart contracts. For example, if you need to do multiple calls to an oracle, you need to call 10 oracles for some reason. A smart contract can do this very efficiently for you. Also, if you need to spend tokens to multiple accounts, you want to spend, for example, make a payout to your stakeholders and pay 30, and 10%. Instead of doing 4 transactions, you can do it with one smart contract call, and it will save you on fees and make it faster and more efficient in general. Also, using multiple smart contracts that call each other is oftentimes helpful to split, first of all, the logic. For example, you have storage and the logic smart contract, they can interact, or you want to integrate a new component, make it as a separate smart contract and just call the old versions of another contract in order to build your system. And it also provides more easy ways to do migrations from from older to a newer contract. When they are separate, you just update the reference in the end. And we always use IPFS for integration of hard data, so data that is too big to be stored in your contract, or that just in general shouldn't be part of your smart contract. Maybe the fees are too high. Have an IPFS node host them for you, and you can always access them, and everybody else can access them too, as long as you put the hash of the data, so the reference on IPFS, into your smart contract in order to refer to it. What are some resources that we use for? We always use Eternity node, of course, sometimes the hosted version of it. We use the app SDK JavaScript to integrate with the node and interact with smart contracts, base app or wallet in order to interact with account, a project to test, have a local contract development setup and test your smart contract, the CLI to interact with the Eternity blockchain from the command line. Eternity protocol definition is always helpful if you need to know how does Eternity work in detail in order to figure out your integration. The testnet is helpful as you can quickly have some tokens and have a instance of the network that feels like mainnet when you use it. So it's of course online, it's synced across the nodes, and but if you lose some tokens, it doesn't really matter. You can use different contract editors, for example the Fire editor or one of the Sophia IDE plugins to have a nice integration within the editor you use locally. Then it's always nice to use the middleware to get aggregated data from the Eternity node. For example, accessing all transactions for one account is not the endpoint that the node provides, but the middleware does, using the blockchain explorer in order to check is this transaction for this account in the blockchain or not. For mainnet or testnet, use the faucet to get free testnet tokens, the compiler or standalone Sophia compiler in order to compile your smart contracts from your app. There's a documentation hub where all documentation is gathered. There's some tutorials for Sophia, and of course there's the app boilerplate that helps you get started quickly using Vue.js and connection to the identity providers. Thank you. And if there's any questions, I will also be in the chat here. And I think we have some time for Q&A. Thank you.
Well, thank you very much, people, for this presentation. I hope you're here with us. You can come to the stage with me, so I'm not alone. Hey,
Hi, how are you?
Fine, very fine. You're good to see you.
Good to see you as well.
So let's see if we have some questions. Otherwise, I always have some. Emmanuel wants to speak. Go ahead, Emmanuel. Come with us.
Hi, Dimitri.
Hi.
So last week, I asked the question of how do you interact with your how do you remotely connect to Base app on your app, in which a user won't have to go through Base app as to call some functions, and people actually give me some links later on, and what I noticed was on those links, those functions and how to do that task were mostly done on Vue.js. So the app I'm currently working on is I'm not making use of any JavaScript framework, and I actually have a code snippet on GitHub gist, in which I still didn't get how to remotely interact with this app.
So last week we discussed about the AEX2 standard and connecting to the Superhero wallet. And this can be done with the links I sent yesterday. And we also, I think we made a forum thread, or didn't we? And to connect to Base app remotely is the same as using Base app, as using the normal Base app integration with the reverse iframe approach. With a reverse iframe approach, and this can be done from any. You don't have to use Vue.js; it will work with any as long as you do it the same way using the JavaScript SDK. I think if there's detailed questions towards this, it would be good to ask it in the forum, and then we can follow up there. Is there any other question?
Yes, there is a couple on the chat. Marco is asking which TTL is the most recommended for a state channel.
I think you have to
Very
TTL yourself.
question.
It depends on your use case. If you want the participants to be active all the time and have it run out quickly, then choose a short TTL. If you think it's better to have it open for a long time, if the participants are not, choose a higher TTL. That's totally up to you.
Makes sense. We have another question. I won't read the chain name from this guy. In terms of smart contracting features for Eternity, do you see something that is undervalued, underutilized compared to other smart contracting platforms?
Give me a second to understand the question.
Sure, no problem.
I don't understand what you mean by undervalued or underutilized.
This guy, you want to come to the stage with us and ask yourself or clarify your question?
So what is unique or stands out is the speed of the execution and the security of how it's executed in the virtual machine with the type safety behind it, and that it's a functional language where you cannot make mistakes easily, and the language will keep you from making mistakes. And also what's very different to how you work with Solidity, for example, is that you can do nesting inside of your data structures very efficiently and cheap. So I think this is the basic standout features. And of course that you can interact with all of Eternity blockchain easily and cheaply.
Okay. About state channel questions, we will have Dimitar after Pivo presentation. So maybe we can save some of those questions for him. We have here. You have on the chat a question from Jet. There is 2 questions. What's your best advice for a user who has issues running local node on his or her system, and where he can make use of a project?
So for running locally, I can recommend a project that works really well, and you just need to have Docker installed, which is possible on any machine, and then a project will spawn a node for you that you can use for local testing. And the second question was, when you spoke about multiple smart contracts, how can you get a variable or function from the other contract? This is documented quite well in the Sophia documentation. It's called, let me look it up.
The remote call,
yeah,
right?
It's under remote call, and called calling other contracts. And there you see an example where you can type safely call other contracts, and it's very cheap in gas. And from these contracts, you can call any of their functions and also use the types that they provide.
Awesome. I have a very specific question for you, Philip. I remember we were working on the governance app we handle here on Uruguay for the digital party. There were a specific function where you needed to get how many tokens a specific address has at a certain point of time. So you were going back on history to see how much it has, and that was a very time-consuming operation. So I was wondering what should be the strategy every time I have some kind of stressful operation like this one or time-consuming like this one in a commercial app. So the app has to be fast, but I need also to be showing that I'm giving you the right information.
So what you can do is, first of all, use some caching. So if the data has been queried before, it's still in cache. And if you query the past balance of an account, it will never change. So you can keep it around forever in a database or in a cache centrally somewhere and verify from time to time, or let the users verify if it's still correct. Otherwise, if you know beforehand that this data will be needed, you can fetch it before and just save it until it's needed by the user or by the process. And if both of this doesn't work, I think you will have to let the user wait and show him some progress bar or something that you're doing. For certain things, what was a very time-consuming operation in the past is getting the total supply. And this is a thing where you don't need the node. Actually, it's a specified function, and you can just implement the function to calculate it locally, and it will be very fast and quick. This is how we worked around this in the governance server. To answer the question from Emmanuel, I think the user should look at what's the problem with a project, and otherwise copy the configuration of the node from a project and run the node manually with the same config that's possible.
Sorry guys, I'm back. Okay, do we have any other question for people?
If there's any issues with the things we mentioned, as Emmanuel said, that the user cannot use Docker when Docker won't start, I think that's a question for the forum where we can interact better.
Yes, that's right. And actually, I think I proved myself. Posting on the forum is very efficient, and somebody is going to be answering very fast. So that's the best way. Also, because other people can have the same problem, same issue on the past or maybe on the future, and they always can go to the forum and get an answer. So that would be the best advice. Okay, so let's move on. Thank you very much, people, for your presentation and for answering all those questions. let's move on for the last part of the session. We have the Ask Me Anything session. So people will let you go.
Thank you.
You're welcome. You're welcome, my friend. The session is going to be held by Dimitar Ivanov. He's an Eternity Code developer. Dimitar is a software engineer, a family man, and a blockchain enthusiast. As a result of his work in software implementation for a banking institution, he was witnessed firsthand this international revenue controlling machine. It's an interesting topic that. His love for blockchain technology is rooted in its potential to disrupt and democratize the world of finance, and his work in state channel and API development is especially valuable because of his openness and open new information. Dimitar enjoys discussing various points of view, so we will have some questions for you, especially one that he disagrees with, and his philosophy of testing logic. Thank you very much, Dimitar, for being here. I hope you enjoy all the questions we will have for you on this session. And you can come up, you can come to the stage with me if you like. Hey, Dimitar, how are you?
Hello. Well, since we're quarantined here in Bulgaria, I'm a bit hairy, but everything is fine. Thank you.
That's something I think is something general. It's something general. It's happening every part of the world. Yeah, having some issues with the hair.
Yeah.
Okay, so I had some questions from before. I have one from Marco. Marco was asking if the state channels can be extended and how many times can this extension be done?
I am not even sure what extending a state channel is. Basically, you as a user can actually interrupt the connection to your FSM as many times as you want, and you can resume as many times as you want. So there is no limit on that. What is really interesting is that on-chain channels are not interrupted. So basically, they do remain, but they don't receive updates. So I'm not even sure what the question is about. If it is about resuming the state channel, yes, you can, of course.
Okay, let's see if we can have Marco explaining better or clarifying his question. Marco? Just write if you don't want to talk. Okay, let's see if we can get Marco clarification. On the meantime, Dimitar, could you explain us a little bit on what is happening with the virtual state channel? What is the status? What's the big improvement in respect of the actual state channel that we have?
Well, I think the most user visible improvement we have is the API of forced progress. Basically, most likely the hardest to produce transaction on Eternity blockchain is the forced progress one. This is when participants take their off-chain state channel and send it on-chain to be executed on-chain. By the way, can you hear me? I see you froze.
I can hear you. I see you froze as well. I will try to reload just in case. Sometimes we need to reload the page to have it working better.
I can hear you well as well.
Okay, thank you. So basically, the forced progress transaction is one that takes off-chain contract that participants have agreed upon. The off-chain state executes that on-chain and validates that the expected result is confirmed on-chain. So it's really hard to get produced without the proper tool, and we already have that. We've also teach the FSM how to recognize those transactions on-chain and to react accordingly. So if one participant does a forced progress, it could as well be a malicious one. Your FSM is going to protect you from any potential harm. It's going to warn you if the other party is cheating, and it's going to provide you with a safe exit, discarding the other participant's transaction. And if the other participant is not cheating, it's going to help you continue from then on. Basically, a false progress is when one participant is either gone missing or refusing to play along, and the other one says, okay, the blockchain can be used on arbiter in this case, and I can use the arbiter now, so I'm right, and the blockchain is going to prove that I'm right. So even if the channels are off-chain entity, they do keep the same level of trustness that the blockchain already provides, so you're safe.
Cool, awesome. Thank you for that explanation. Maybe you answered this part and I didn't hear. I was reloading the page, but there is something is always coming back to my head, and how it works the first time. Let's see. I'm walking on the street. I stand next to a cafe, and I want to buy. It's the first time I'm getting to that place. So that's some of the usual cases we have for state channels. How it happens the first time, how it works.
Well, it depends. Now it's a bit cumbersome, as you have to. Well, it depends on how much money you want to spend in the cafe, really. So channels can be opened really fast. But this makes them vulnerable to forks. Basically, channels are opened with an on-chain transaction, and in order for you to be safe, you would want to wait enough confirmations for it to happen, as you would with any transaction, really. So opening a transaction is slow, but a potential future where we have virtual state channels, this would not be a case anymore. Virtual state channels are state channels that are using existingly opened state channels to create a new state channels inside of them. So in your use case with the cafe, you go to the cafe and you find out that your friend Bob already has a state channel with them, and you have a state channel with Bob. So you actually open a state channel with the cafe using your connection with Bob and Bob's connection with the cafe. So what you actually get is instantly opened state channel. This is not opened on chain, so this is opened with Bob being used on arbiter. So it's near real time, and when this happens, you don't need to wait confirmations on chain. You get your finality right away. So this is what we're aiming at, really. You get instant real-time confirmations of your transactions, opening and closing state channels on the go.
Cool. Yeah. That's what I like of the way you guys are receiving our input, right? Because you build something, you see how it works in real world, then you have to go back and improve it and see how it is going to be working. So that's a great interaction between both worlds, and that is needed to improve the platform, to improve the protocol, and to make it the best way as possible. Because at the end, I would like to do that. I would like to take a coffee and knowing that my transaction is going through state channels really fast. So awesome. Thank you for the explanation. It was really clear.
I have some feedback from Marco, who for some reason cannot load Jitsi because he has a bad internet connection. So about the question before about the TTL, he was asking like for 1 month, like how much, like I also don't understand the details, to be honest, but he was just asking for 1 month what is the suggested TTL.
I guess first of all transactions have TTL. And I'm pretty sure Marco is asking for not the TTL, but for a lock period interval. So TTL is a means to provide that your transaction eventually either gets included or kicked out of the blockchain pool of unconfirmed transactions. So what the TTL is, you can define when your transaction can be included at the highest point of the blockchain. So this goes with state channels as well with spend transaction, Oracle transaction, name transaction, whatever. So if I set block height 300,000, this is the maximum block height that can actually include my transaction. If it gets included later on, this would be invalid block. So basically, this is what TTL is, and it's not channel specific in any way. But channels do have time interval which is intended for disputes. So in our case, where one party is cheating the other one, possibly using forced progress, so close with the previous state or something. And then the other party has time to react, basically, in order to protect himself or herself with the malicious actions, discarding malicious actions of the previous party. And I think Marco is talking about this time frame. And what this actually is really use case dependent. So let's say I have Alice and Bob have a state channel, and Alice goes to the beach and she zones out for a month. And in this case, after that month, if the lock period had been 1 month at channel opening time, Bob can actually close the channel by himself. And if 1 month is enough, I don't know. It really depends on the use case. Bear in mind that every slash, let's say, resets this timer. So if they have 1 month timer and Bob posts a transaction and now he has to wait 1 month for the channel to be finalized and closed on chain. If Alice appears and slashes his transactions, the timer is reset. So it really depends. I cannot suggest any time frame. If you plan on zoning out for 2 months, probably 1 month wouldn't be enough for you. Possibly 1 week would be enough for most use cases, but I wouldn't put my name on that.
Okay, Eric, do we have any other question for Dimitar?
No, it was just the two that you also posted in the chat before.
Okay, great. So if there is anything else, I would like to thank you, Dimitar, for all your time and your explanation. At least I learned something, so that's good. And well, let's see. Maybe there is something new on the chat. Oh, okay. There is Marco saying thanks. Okay, so thank you very much, Dimitar, and thank you to everybody to be here on this session.